Hey there YouTube, petey twofinger here. We're going to be talking about a current test. This is determining how much current is your device drawing. Now this is important when you're running stuff off of batteries, and this is going to be really basic. It's just going to show you how to perform that test with your typical multimeter. So what you need to know when doing a current test is most often you need to switch over your probe. In my case, on all of my meters, you move the red one over to the other side, and then you set it up to wherever that test is on your thing. And it's also fused, because what you're doing when you do a current draw test, the meter becomes part of the circuit. So what I mean by that is here's my power, here's my battery, and here's my circuit. So normally you would have black wire and a red wire going right into this, and that would light up and it would work. Well, what we're going to do is we're going to sever the black wire, and we're going to take one end of it and connect it to this probe of the multimeter, and the other probe of the multimeter, you guessed it, goes to that other wire that we broke. So you need to be able to hack in or cut one of the power wires. It doesn't matter the plus or the minus how you hook this up. If you hook it up backwards, you will get a reverse reading on your multimeter. Now that's if you're using an auto ranging digital multimeter. If you're using an old analog one with the needle, it's going to push that needle down, and you're going to have to adjust it, flip-flop your polarity. So just kind of pay attention to how that would work. So the story with this is it's for a powered mixer. The powered mixer, we're running 3 stereo channels. So here's a pair of preamps, here's a pair of preamps, and then there's 2 stereo bank channels that don't have those preamps. So I was like, you know what, we really need a preamp for that third stereo pair. And I found one on eBay for $2, and it came with these 2mm connectors. I need to know what these are called. If anyone knows what these are called, I want to order some of these specifically. Anyway, what we're going to be doing today is feeding audio in and coming out into a little powered speaker, and we're going to turn our volume down kind of quiet on our sender, and we're also going to have the volume down on the speaker because it's going to be preamping 5x, and then we're going to test it for current draw, see what numbers we get on our meter, testing it at 12 volts and then at 24 or 25 volts. We're going to see, because my hunch is that number is going to double. That this device is going to take whatever it can get as far as the volts, and that's reflected in the current as well, because all this stuff is part of an equation. And you could think of how they say, well, it ain't the volts that'll kill you, it's the watts or the amps. That's what we're measuring here, the amps. So when you see a wall wart and it says 9 volt 1 amp, or 9 volt 300 MA, that MA stands for milliamps, and 300 milliamps is 1/3 of an amp. 1000 milliamps would be 1 amp. So this is how this works. We're talking about DC single supply stuff. Like I said, this was $2, and it came with a pair of these cables. I asked them, hey, how much for just the cable? He's like, how many do you need? I said, 4 or 6 of them. He said $3.97 each per unit. When the whole preamp with 2 cables is $1.96. So the reason I'm testing this is because on the auction page it says current draw 600 milliamps, which 500 milliamps is a half an amp, but I'm like, there's no way this thing, the chip, there's no way this thing would consume that much power, because I know a little bit about this stuff, and I know how much an op amp, like you think of an old fuzz or a booster pedal, like how long is a battery going to last? Let's say you have an active bass, you play that every day, that battery should last 9 to 12 months. And I'm thinking, well, if it was 600 milliamp, the battery would be dead in a couple of weeks. And there's no way that this little tiny preamp circuit is drawing that much power. There's no way. So it says on the auction, whenever you see one of these, they've all copied and pasted the same text, and it's all wrong. And I'm guessing they meant to put 60, which if you look, they added extra zeros because they thought that number's so low. 6, it looks like it's really weak. Let's put 600. And then people will buy it, because this is part of that language barrier that you run into, is people fudging the numbers all the time. And I think what we're going to see is it's going to be much closer to 5 or 6, because when what I did, if you look at the unit, it has a chip, and that chip says NE5532, which is a real common dual op amp. So I typed into my Google NE5532 data sheet, and that pulls up a thing. Texas Instruments, the manufacturer, whoever made the chip, has a data sheet. It's all kinds of confusing graphs and numbers and different words that are kind of above my pay grade. And you look at that, what you're looking for is quintessent, or Quint, the guy with the boat. We're going to need a bigger meter. That guy, it'll say quintessence, and that's like the current. Is that at idle, or is it when you're cranking up your sleigh? I'm not sure if there even would be that much of a difference, but we're going to take a look. Now, how you set this test up is in eliminating, let's say you already know how to get the audio in and out of it. You're just going to need a couple of power wires, right? You're going to need your plus and your minus going from the battery or power supply to the circuit. So what you do when you want to do a current test, a current draw test, to see how many milliamps or amps that your device is drawing, you have to move this red one over to where it'll say MA. Usually that's fused through, because the meter is going to be serving as a wire. You're going to hook this up in between. Let's say you just eliminate one wire. Let's say you eliminate, we'll pick the ground. We'll leave the plus wire, the red wire, connected. Then what you're going to do is you're going to put one side of the meter on the other battery terminal, the ground battery terminal, and then this other probe goes to the ground input on the circuit. So then literally the current is going through your meter. It's going through, and then it'll tell you, almost like a gas gauge, it's telling you how much that it's draining out of that battery. So what we need to do is fire up our cable. Get that really quiet. Alright, plug that into the input there. And then this sucker, that's my little powered speaker. We'll turn that down a couple notches. We're going to try it first at 12 volts, and then we'll try it at 24 and see what we get. Okay, so the LED is kind of barely lit. This board runs between 5 and 30 volts. So right now it's drawing 3 milliamps. And let's this came off here. And what do we got? 5, 6. So it's teeter-tottering. And let's do this again. I can't really tell the difference between, but I'm going to run this off of peak voltage. It's going to be run off 24 volts in the circuit, and we can see it's only drawing a total of, on my meter it's showing 0.05, which is 5 milliamps. So let's bump it up. All right, rock and roll. So that's how you do the milliamp test. Like I said, you gotta boop, move that one over, and then you connect it through your circuit, meaning your plus and minus go from your power supply or battery into the circuit board, and then you just break one of those wires and cut your multimeter in between, And this one has two settings. One is DC milliamp and one is DC 10 amp. So that just moves the decimal point. But this test, you got to remember to move it back because I always forget, and then why can't I get continuity? And basically, to explain adding the preamp, it's again, this is the powered mixer that I built. It's got 3 power packs to power the mixer circuit, which is up here, the mixer, and then these 2 batteries are on their own. They run this MP3. So how it works is inside of here, there's 3 of the 4-volt cells equals 12 volts. Okay, so we have 12 volt and then another 12 volt battery, another set of 3, and another set of 3. All 3 of those come out with their plus wires connected into one, and then the minus wires connected into one, and then it shoots through a fuse and goes to the mixer. So I will have the 3 battery packs. It'll last longer than if I just had one. So that's series wiring, the 3 in a row, to 4 to 12, and then the 12 to expand to get more current, to get more milliamps. I'm connecting those 3 in parallel. And the reason that I'm adding this preamp is because this channel here, this stereo channel for the MP3, has the gain. There's gain knobs up here which really boost the volume. It's a preamp. There's a stereo preamp on this these 2 channels. There's another stereo preamp for this set of channels. But then when you get over here, there's 2 stereo channels, 2 pairs. And those, they do not have the preamps. So we're running a guitar, a bass, and an MP3 player. And while I don't necessarily need all 3, I'm going to put one on it, and I'm going to run the MP3 through that to give me a little more headroom and a little more leeway. And like I said, I was just concerned because we had crashed out our battery pack. When I initially designed it, I only had 2 of those sets of 3 to get to 12 for the mixer, and the batteries died after about 8 hours. And so I added a 3rd pack, and it still kind of really drained them out. And then I was thinking, well, I don't want to be really putting drain. You know, I looked up I had ordered these because every time I build an amp, a Class D amp, I like to run some sort of a preamp or an EQ in between the MP3 player and the amp, because I feel that the MP3 players are weak on their output. So something to boost it up a little bit helps. And I could have just used the built-in pair of preamps for this, but then I would have been shy one for the guitar or the bass. So the thing was, I had ordered these, they came, and I went back and looked at it, and it said 600 milliamp draw, and I'm like, that's crazy. So I hooked this up. It was a whole unbelievable waste of time today. I made a video on how to solder using flux, which that's not the first time I've done that. Anyway, thanks for joining me. Look forward to more actual live music with this equipment on this channel, and more DIY electronics and all kinds of fun stuff. So, peace.
Say bye-bye. Say bye-bye. Bye-bye.